Hi everyone, I will show you today how to plot the data from DeepSoil file. So when you have a DeepSoil files as Excel file, you're gonna have a large amount of data, especially if you have like more than 10 or 20 motions. Excel sometimes cannot handle large amount of data. So I'm using Matlab code to just plot the data in this format. So I'm plotting the spectral acceleration versus period, Fourier amplitude spectra versus frequency, and then acceleration, velocity, displacement, time history with areas intensity. So as I said before, the Excel cannot handle too a large amount of data, and especially if you want to plot them, sometimes Excel use a large amount of memory, and it will at some point it will stop responding to your commands because it just cannot handle that much of data and plot them. So we usually go to Python or Matlab or any other open source platform to plot these data. Here I'm using Matlab. So let's see now how the data looks like from DeepSoil. I'm opening the Excel file now. So what you have here, like maybe 10, 20 motions, and each motion has a lot of data. Here I'm showing motion 5779 east-west component. As you can see, it has time, acceleration, velocity, displacement, time history, area intensity, period, etc. So deep soil plot them as this format, which is very ugly. It's not that good. You cannot publish these data, and you cannot like put them like this in any documents. So, and if you have more than like 10 motions, the Excel file is gonna respond very, very slowly, and it's very hard to handle this amount of data. Okay, so let's take a look on the code. In the first three rows, I'm just cleaning and close all the windows from previous analysis. In this line 6 here, I'm defining the Excel file name. So whatever that Excel file that I showed you, you just put it here with the extension. And then you define the sheet name, and then you define the range of data using XLRange function. Okay. After that, you define the data, which is gonna has the function XLRead. So it's gonna read the data. Which data? The data that has that is inside this Excel file name and inside the sheet name, which is this one, and then within this range, which is A3 to Q90,000. If we take a look again back to the Excel file, we see that the data starts from column A, row 3, and it ends at column Q. I gave it just maximum number of rows, which is 90,000. Here we have maximum rows 8,193. So I'm just giving extra just in case if there is motions that it has very long period or long duration, so it can read all the data. Okay, so it's very simple and very straightforward. Here now in row number 11, plotting the spectral acceleration using subplot function. So subplot function, you need to define the total numbers of rows and the total numbers of columns. And then you need to define where is that plot will be in which cell. So let's see here. We have 1, 2, 3 columns, and then 1, 2, 3, 4, 5, etc. until um, 12. Okay, so I'm saying that the subplot of spectral acceleration is going to take place in 1, 4, and 7. So this is 1, 2, 3, 4, 5, 6, and this is 7. So I said it's 1, 4, and 7. So the spectral acceleration plot is going to take all this space. I'm not using column 3, I'm just using column 1 and 2. Okay, so this is the spectral acceleration. It's going to take all this space. Then I'm going to leave a row here and then start writing down the other plots, which is the acceleration, velocity, displacement, and area's intensity. After I defined the location of the spectral acceleration plot, I'm calling which data I want. So I call it here P, which is like a stand for period. It's going to be in data or the rows number, column number 8. So this sign here means all the rows, okay? And then this number here means the number of columns. So here columns 1, 2, 3, 4, 5, 6, 7, 8. So you see the period start at column 8 and line 3. So you see here column 8, and doesn't matter which row because this symbol means all the rows. Just read all the rows in column number 8. So this is the period. Okay, how about the spectral acceleration? So it's going to be in all rows, it's going to read all the data which is defined here, all rows and row number 9. So this is number 8 and this is number 9. So this is a spectral acceleration that's going to read. So here we defined the period in data, all rows, column 8, and then the spectral acceleration, which is in data that we already defined here, all rows, columns number 8, and then plot them. Plot both P and SA, okay? And here I'm defining the line colors as a solid black line. K means black, okay? And then we are defining the x-axis as a log scale. And then I'm giving here labels to the x-axis, which is period in seconds, okay? And then font weight is bold, okay? And then the same thing for the y-axis. This is the labels in the y-axis, and the font of this labels is going to be bold. And here I'm activating the grid for this plot, so the grid is on. And now here I'm defining the locations of the sheet. So as you can see in DeepSoil, each sheet has motions. Okay, so this motion is 5779 east-west component, so it's gonna have the same name in the sheet. Okay, so I'm saying, okay, print the sheet number on the top of the plot of the spectral acceleration. Give it color black, and then the font size 13, and the font weight is bold. That's it. This is just the location, so it's taking 0.012 on the x-axis and 1.75 on the y-axis. This is just to define the location of this text. Okay, let's take a look again into the subplots altogether. Let me show you what I mean by this line here, number 20. So it means make it bigger. So you see, this is what I meant here. This is the text that I was talking about. So it's going to be on this location, 1.75 in Y and 0.012 on the x-axis, and it's bold, font size 13. Okay, this is just one way to define this text. There's too many different ways to define the text in Matlab, but I'm using this way to define it. Okay, so same thing again for the Fourier amplitude plot, which is this one here. So again, I'm using now, instead of semi-log like spectral acceleration, I'm using log scale for both axes. So you see here log for x-axis and log for y. I'm using the grid here 12, 13, and then I'm taking the space 2, 5, 8, and then calling the data all rows in column 15, then all rows in column 16, then plot both of them in black color. And then the same thing in defining the x-axis labels, y-axis labels. Same thing for acceleration. So here I'm taking 13, 14, 16, 17 grid or space in the subplot, then defining the time, and then the plot acceleration, which is the second column in the Excel file, and then plot both of them in red. R stands for red here. And then defining the same thing, I'm defining the labels and the x-axis and the y-axis. Actually, I'm not defining the x-axis because I'm not using any labels on the x-axis. I'm using one label here at the end, where at the x-axis of the area intensity plot. So instead of repeating time, time, time here again, I'm just using one time as a label defining the time at the bottom of the area intensity plot. Okay, so that's it. It's gonna continue the same thing for every single plot, the same idea. Here I'm just using a different function to define how many numbers I want after the decimal. Here I'm using um, just one. Okay, you see the area intensity has one number after decimal, and that's it. Hope, hope I hope you will like this video. Um, Please don't forget to like and subscribe, and you can just pause the video and just write the code, and hopefully you get some benefit from this video. So again, as I said, it's going to save a lot of time. Excel sometimes cannot handle large amount of data, and this is I think very helpful and useful if you use it to read any Excel file from DeepSoil. Thanks. Bye.